B. This lesson focuses on Eulerizing circuits. So it's on seeing graph, realizing that you can't make an Euler circuit out of it, but then being like, but I need to. So how can I fix it so that it is Eulerized for me? So this is often called the Chinese postman problem. And the reason that it's been called that for so long is because it was first studied by a Chinese mathematician. So truthfully, I don't like that. We should call it by his or her name. You know what? Let's make that change, shall we? Okay, so when we look at this problem is, what if you are a mail carrier, right? You're delivering mail. And unlike with the snowplow, when you just need to do the whole street, with mailboxes, oftentimes you had mailboxes on the side of the street. So just because your car is on the street doesn't mean you're able to hit both sides. Does that make sense? So in that case, you do need to get both, like you do need to get that one edge twice. So that's kind of the issue we have here. So in this first picture right here, we've got how the mailboxes are set up. So you'll notice that like B has mailboxes on that side and on that side. But C doesn't have any mailboxes right here, so maybe that's like a park or something, and there are mailboxes on that side. So when it is written as a graph, notice how B has two edges between it. B and F, I should say, have two edges between them. Okay, so as we look at that picture, which of the vertices in that picture have odd valences? So A is fine, right? A has 2. B has 1, 2, 3, 4. B's fine. C has 3. D has 2. H has 2. G has 3. F has 4. E has 2. So those two right there, C and G, are the ones that are odd. Those are the ones that right now are making it so that we can't make an Euler circuit. So what we need to do to Eulerize is that we duplicate either one or more edges so that we can make an Euler circuit. So it's not that you're creating a new edge, because that would be like creating a new road. Like, oh man, I don't want to drive that one road once, so I'll just go ahead and drive through people's lawns. That's not okay. People don't like that. So you have to still be on the same roads that already exist. You're just going to do it more than once. So what we do in this case, and you'll see it's already drawn for you, so I'm going to highlight it. What they did is they added an extra edge, but really all it is duplicating an edge that's already there. And the way that we show that it's been duplicated is we give it like an arc to it, like how the 2 between B and F are arced, so that you can tell that it's 2 separate paths, even though it's the same road. It's like one side and then the other side of the road. So if you were going to do this in real life, if you were actually going to solve these kinds of problems, there are a few things that you would need to consider. One of them, like we talked about, is that you can't create a new road. Okay, you can only duplicate a road. And then another thing is that when you add an edge, that means that you're going to turn around and come back. Which makes sense. Those of you that live like in a neighborhood, like maybe that has a cul-de-sac or something, you'll notice that like the garbage truck has to like come down and then they have to like turn around. And if it happens early in the morning in your neighborhood, like it does in my neighborhood, you can hear them doing their fun like reversing beep sounds while they maneuver the truck around, and then they're able to go the other way. So because the garbage truck also needs to pick up stuff on both sides of the street. So there are hints to Eulerize efficiently. Okay, one of them that we already talked about, like this middle here, you cannot do this. This is not okay, right? So in this picture, both X and Y, both of those vertices have odd valences. And so this person was like, cool, if I draw in this pink line here, then that makes X and Y both even numbers. And that's awesome, except this is driving through, I don't know, a park. Like, you're not allowed to just drive wherever, you only drive on roads that already exist. So if you did it, you could go like from here to here, and then from here to here, but then you'd also, of course, have to go from here to here, right? Which is right here on this picture. And the reason why you'd have to do that is this. In the original picture, this is a 3, and this is a 3, right? Both the X and the Y. And then this to the right of the X, 1, 2, 3, 4, this is a 4, this is a 4, this is a 2, and this is a 2. So when I draw from here to here, a little arch showing that I'm going to have to do that one edge twice, that makes this a 4, which is great, but now it makes this one a 5, which is not great. So then I fix the 5 to make it a 6, and crap, I messed this one up, and now it's a 5. So again, I got to fix that one by drawing from here to here. This is now a 6, but hey, that also fixed this one. It's now a 4. So oftentimes, in order to fix just like 2 of them, you often have to change the ones in between, because that's the only way to do it without creating a new road. If you have a rectangular network, which often happens like with a city block or a few city blocks, you want to do what's called edge walking. So what that means is that you want to do let's follow the directions here. You start in the upper left-hand corner. So you would start right here, okay? And you're going to go around the edge. But if you get to an odd edge, then you're going to fix it right away. So like I would start, I'm going to blow this up. I would start here, and I'd call that 1. I'm going to make my pencil smaller. Okay, but then this is an odd valence. So I'm going to need to duplicate. So now this is a 4, right? It used to be a 3, and this one's a 4. It also used to be a 3. So I would I travel this part first, 2, and then I could come back 3. And then I could go down 4 over 5, up 6 over 7, down 8, right? Everything so far now has been an even balance. I'm fine, I'm fine. I came to another one that was bad, so I got to blammo, pop in another one. So, okay, I can travel, like you can travel the arch now like we did up there, or if you want to do the inside first and then go to the outside, that's fine. So I can try that here. I can go over 9, down 10, over 11, up 12, archy down 13. Okay, and then 14, 15. Ooh, I gotta fix this one too. Blammo. And you're just gonna continue on through the picture. All right, this is the end of the lesson, so this is the next time that you have a little quiz.